Here we are on top of the stars. Never thought we'd ever get there.
Okay, I will solve problem number 10, and that is this one that is appearing below. Okay, so now we can proceed with the solution of problem number 10. So, the first step is to arrange the exponents in order from greater to smaller, so we can compare it with that other binomial and see if the substitution method can be applied. So we can see that 3 minus 2 is 1 and 1 minus 0 is 1. So we can proceed with the substitution method. Okay, so now we need to find the u. The u would be the binomial with the greater exponents is inside the parentheses. So the negative x cubed plus 2x would be our u. And our dx would be the du over the differentiation of the u, which is the negative 3x squared plus 2. Now that we have that defined, we can proceed with the algebraic expressions. Okay, so we have that the integration of the 18x squared minus 12, this one stays the same, and times the u. Now we substitute this binomial with the u to the 7th power, times the dx, the dx is the du over the negative 3x squared plus 2. So then the next step would be to factor out a negative 6 out of here in order to cancel out these two binomials, right? So we end up with something like this, that is a negative 6 times u to the 7 times that du. Okay, so then we can find the integration, which is the negative 6 times the u to the 8, because it's 7 plus 1, 8, divided by 8, plus a constant, that is the c. So now we can simplify this expression into this one with factoring out a 2. So we have negative 3 over 4 times the u to the 8 plus c. So the final step would be to have the integration of f of x times dx equals the negative 3 times the negative x cubed plus the 2x of that binomial to the 8th power divided by 4 plus a constant.
To integrate this problem, so we send the denominator as numerator with the exponent as negative, changing the square root. Then we have to check if it's complied the rule by the method of substitution, and checking by it's an x squared, then it has an x, then it's a number, then here is anything. So it's complied. And we have to choose the u because it has the exponent. Then this is the u, then we have to derivate the u, and it's negative 8x, then send it dividing the du as du negative 8x equals to dx. And then Kanati will explain the next steps.
Okay, now that we have our dx, we will substitute in our formula by giving our first value, then changing our u as a variable of u and leaving it with the same exponent. Then, since instead of having the dx, we will substitute it with the equivalent as du over negative 8x as shown here. After that, we will simplify, cancelling the negative 8 by the 16, and it will leave us a negative 2, and the x's cancel themselves. After that, we only need to integrate, since it's already simplified, so you add 1 to the exponent, and it will be negative 1/2, and then flip it and multiply it. It has to be negative since the exponent is also negative. So it's negative 2 times negative 2 equals 4, and then divided by 1, it stays the same. After that, you just pass it to the bottom since it's a negative exponent, and change it to radical. After that, you change the u with the u that you used here and add the plus c.
And then, as a result, we have this 4 over the u in here. And don't forget to put the plus c.
In this problem, number 3 of the projectile, the question A asks for the change from the 10 degrees to the 11, the exact change. So we use, basically we're looking for the increment. So we use the basic formula of delta y equals y2 minus y1, or x in this instance. So this is our equation, our function, and we simply we have the information that the initial velocity is 2,500. So we're basically placing the equations with the numbers, the variables, and add the second angle, of degrees, and then the first, and we just subtract them, and we get our delta y, which is this.
Okay, so in question number B, they ask us for the differential by approximation. So in this case, we grab the formula or the function, we derivate it, and it gives us this one, and times the dx, that the dx is the difference between both x. In this case, it's 11 and 10, so the difference is 1. And then we just input the variables, that this is the velocity, the first angle, that we always use the first angle, and the dx, and this our dy.
Yeah.
Well, the context in the situation, it's a projectile that has initial velocity of 2,500, and it tells us that the degrees of the inclination of the projectile change. So all the distance that it covers will at the end change, and we tried 2 different ways and got different results. In this case, we got really far apart results that they don't match, and well, but we followed the formulas, the procedure, and this is what we got.
So we rather use the increment formula, because in this one we compare both angles, and in this one we just use one angle, that's the first one, so we don't get the same results or as exact results. So we prefer the increment formula.